NASA just made a huge discovery. There are planets only 40 light-years away that might have water and even life. This system, called TRAPPIST-1, has 7 rocky planets. Some of them might have oceans or thick air. It's the best chance to find another Earth. But the biggest surprise, one of these planets might hide something huge. Tune in, because what NASA found will blow your mind. NASA's groundbreaking discovery in 2017 revealed that a small, dim red dwarf star had a jackpot of Earth-sized worlds orbiting it. What made this discovery even more thrilling was the fact that several of these planets lay within the habitable zone, where temperatures might allow water to exist on the surface. And not just 1 or 2, but a stunning 7 planets, all locked in a tight orbital dance around their faint reddish sun. Scientists were left in awe. Never before had such a compact, rocky planetary system been found, let alone one with this many potential second Earths. But then came the twist. What they found next will blow your mind. Since then, astronomers have been throwing everything they have at TRAPPIST-1. The Hubble Space Telescope, Spitzer, Kepler, and now the powerhouse itself, the James Webb Space Telescope, have all been used to study this fascinating system. Every new observation peels back another layer, revealing just how complex and strange these planets really are. The first major reveal from Webb came in March 2023, when it focused on TRAPPIST-1b, the planet closest to the star. It turns out this world is blazing hot, with no real sign of an atmosphere. That's one planet crossed off the list for habitability, but there are still 6 more to investigate. Back in 2018, deeper studies of the system suggested something even more intriguing. Some of these planets might hold more water than Earth, and not just in small amounts. Some could be drenched in massive oceans, while others might have thick, steamy atmospheres rich in water vapor. The farther out planets could be wrapped in endless ice, frozen over in an eternal deep freeze. The variety within this system is what makes it so compelling. The density of each planet was also nailed down with greater precision, making TRAPPIST-1 the most well-understood exoplanet system outside our own. Then, in 2021, scientists uncovered something unexpected. These planets all seem to be made of the same basic materials as Earth: iron, oxygen, magnesium, silicon, but their density suggests something is off. They're about 8% less dense than expected. That might mean their composition is completely different from Earth's. Are they packed with water? Do they have thick, fluffy atmospheres? Could they be hiding something entirely new? The mystery deepens with every new piece of data. Now, imagine standing on TRAPPIST-1d, the 3rd planet from the star. The red dwarf looms huge in the sky, bathing everything in a dim, reddish glow. The landscape could be anything: rocky terrain, frozen tundras, or maybe even vast oceans stretching as far as the eye can see. Look up, and there they are. 6 other planets hanging in the sky like giant celestial ornaments, close enough that you could make out their shapes and colors with the naked eye. They'd appear bigger than our moon does from Earth, a constant reminder of just how different this star system is. Shift over to TRAPPIST-1e, the 4th planet, and the environment changes again. This one is considered the most Earth-like of the bunch, with a real shot at having liquid water. Some models suggest it could be a water world, a planet covered almost entirely in oceans, with permanent twilight casting an eerie glow over the waves. Its sister planets would be visible in the sky, lighting up the heavens with their proximity. Every night would be a reminder of the strange, alien world you're a part of. Exploring these planets firsthand might still be a distant dream, but thanks to NASA's interactive models and digital simulations, you can take a virtual trip through the TRAPPIST-1 system right now. You can compare each planet to Earth, see how their habitable zones measure up against our own, and visualize what it might be like to stand on their surfaces. It's as close as we can get to visiting another star system, and it's available at the touch of a screen. The research into TRAPPIST-1 isn't slowing down anytime soon. Every new study brings more details, more questions, and more excitement. Are these planets truly habitable, or are they just another cosmic tease? Could one of them be home to alien life, even if it's just microbial? The only way to know for sure is to keep looking, keep studying, and keep pushing the limits of what we know about the universe. TRAPPIST-1 isn't just another planetary system. It's a front-row seat to the future of space exploration, and it just might hold the biggest discovery of all time. Now let's talk about what makes this planet so interesting. First, its size. Gliese 12b is only about 10% wider than Earth, meaning it's much closer to our home world than most of the giant gas-covered exoplanets usually found. That alone makes it worth a second look. But what's even wilder? This planet zips around its star in just under 13 Earth days. A year on Gliese 12b is not even 2 weeks long. That's because its star is much smaller and cooler than our Sun. So even though it's way closer to its star than Earth is to the Sun, it still sits in the so-called Goldilocks zone. If scientists can confirm Gliese 12b has an atmosphere, it could be one of the best places to study how planets develop and what makes one habitable while another turns into a toxic wasteland. Right now, they think if it has an atmosphere, it's likely thin, possibly something like Earth's. That's actually good news. Too much atmosphere, and it ends up a suffocating, overheated mess. Not enough, and any potential life gets fried by radiation. We dive deeper into Gliese 12b, uncovering surprising new details. One of the biggest mysteries in planetary science is why Venus turned out so differently from Earth. By studying Gliese 12b, scientists hope to get some answers. Did it keep a stable climate, or did it go the way of Venus? Understanding this could tell a lot about how planets evolve and whether life-friendly worlds are common or rare in the universe. If the conditions on Gliese 12b are anywhere close to what Earth had in its early years, it might reveal whether planets like ours are flukes, or if life has had countless opportunities to emerge across the galaxy. Here's another thing. Red dwarf stars like Gliese 12 are everywhere. They make up about 70% of all the stars in our galaxy, and they live a ridiculously long time, sometimes trillions of years. That gives life an enormous window to develop, assuming these stars don't constantly blast their planets with deadly radiation. Some red dwarfs are known for their violent outbursts, which can strip away atmospheres and leave planets exposed to the harshness of space. The good news? So far, Gliese 12 seems to be relatively calm. If it stays that way, its planet might just stand a chance at developing the right conditions for life. The hunt for more details on Gliese 12b is already underway. Scientists are turning to more advanced tools like the James Webb Space Telescope to peek into its atmosphere, if it has one. They'll also use the radial velocity method, which measures the tiny wobbles of the star caused by the planet's gravitational pull. This will help nail down its mass and composition. Even if this planet isn't habitable, that doesn't mean the search is over. Every new discovery teaches something, and this is just the beginning. With technology improving and new telescopes coming online, the hunt for Earth's twin is only getting started. Each step brings scientists closer to answering one of the biggest questions of all. Are we alone in the universe? Gliese 12 might not be humanity's future home just yet, but it's a major step in the right direction. Whether it's an Earth-like paradise, a Venus-style disaster, or something completely unexpected, one thing is clear: our universe is full of surprises, and we've only just begun to uncover them. But TRAPPIST-1 and Gliese 12b aren't the only promising worlds. Beyond these systems, astronomers have discovered other planets in habitable zones, and one of the most intriguing finds is TOI 700, a stellar system that has unveiled several surprises in recent years. Now, this isn't the only rock in the neighborhood. Astronomers had already spotted 3 other planets, TOI 700b, C, and D, hanging around this same system. Planet D is also in the habitable zone, meaning there are now two potential Earth-like worlds circling this small, dim star. But TOI 700e took a little longer to confirm. Scientists had to gather an extra year of test data to spot this smaller, fainter world. This discovery is a big deal. There aren't a lot of multi-planet systems like this where habitable zone planets are confirmed. That means TOI 700 is now a prime target for further research. Scientists are eager to take a closer look at what these planets are made of, how they formed, and just maybe, whether something is living there. TOI 700 is a red dwarf, a type of star that's smaller and cooler than our Sun. It's parked about 100 light-years away in the Dorado constellation. Back in 2020, astronomers first identified TOI 700d, a roughly Earth-sized planet taking 37 days to complete one orbit around its star. With the discovery of TOI 700e, things just got a whole lot more interesting. Here's how the planets stack up. TOI 700b is the smallest, about 90% the size of Earth, and circles its star in a super short 10-day orbit. TOI 700c is the heavyweight of the bunch, more than 2.5 times Earth's size, taking 16 days to complete a lap around the star. Then there are TOI 700d and e, both of which sit in that promising habitable zone. The entire system is likely tidally locked, meaning each planet probably always shows the same face to its star, much like our moon does with Earth. TESS is designed to stare at vast sections of the sky for about 27 days at a time, watching for the tiny dips in brightness that signal a planet passing in front of its star. Back in 2018, the satellite started scanning the southern sky, then moved north. By 2020, it returned to the south, and that extra round of observations made all the difference. It helped confirm that TOI 700e was really there. What does this all mean? In simple terms, scientists are getting better at finding smaller, Earth-like planets in the right spots. The habitable zone is split into two categories. The optimistic zone, where liquid water could have existed at some point, and the more conservative zone, where water could last for most of a planet's lifetime. TOI 700d sits comfortably in the conservative zone, while TOI 700e edges into the optimistic range. The more planets found in these zones, the better scientists understand how common Earth-like worlds might be. That's huge for figuring out the bigger picture of planetary evolution and, ultimately, the chances of finding extraterrestrial life. The hunt for life on TOI 700 intensifies with exciting new findings. This system isn't done giving up its secrets just yet. NASA plans to keep a close eye on TOI 700, using both ground-based telescopes and other space observatories. There's a chance further studies could reveal atmospheric details, maybe even signs of biological activity. Scientists are already scanning through TESS's massive data archive for more hidden gems like this one. The sheer number of planets already uncovered by TESS is staggering. Thousands of potential exoplanets have been detected, with hundreds confirmed to be real worlds. Among them are gas giants, ice worlds, and rocky planets like Earth, scattered across the vastness of space. Some orbit sun-like stars, while others cling to the dim light of tiny red dwarfs like TOI 700. With each new discovery, the puzzle of our place in the universe gets a little clearer. It is not just about spotting planets. The real excitement comes from figuring out what is on them. Scientists use telescopes to analyze light passing through distant atmospheres, searching for chemicals that might hint at alien biology. If TOI 700d or E has an atmosphere rich in oxygen, methane, or other gases linked to life, the implications would be staggering. Even if life does not exist there now, the TOI 700 system gives scientists a window into planetary evolution. The differences between its planets, some in the habitable zone, some outside, provide a natural experiment on how worlds form and change over time. Studying them could reveal how Earth itself might have evolved differently under other conditions. There is also the question of whether these planets have water. Liquid water is considered essential for life as it is known, and while no telescope today can directly see oceans on exoplanets, scientists have ways to infer their presence. A planet's size, density, and distance from its star all offer clues about whether water might be flowing on its surface or locked away beneath a thick ice shell. As the search continues, TOI 700 remains one of the most exciting targets out there. Its small, cool star might not be much to look at compared to the Sun, but the worlds orbiting it could be among the most important ever found. Whether they hold life or just the potential for it, they are teaching scientists more about the universe with each new observation. That's where the Transiting Exoplanet Survey Satellite, or TESS, came in. Launched in 2018, TESS took exoplanet hunting to a whole new level. Instead of staring at just one patch of the universe, TESS scanned nearly the entire sky, searching for planets around bright, nearby stars. Why does that matter? Because planets around closer stars are easier to study in detail, and TESS delivered thousands of potential exoplanets, some of which are now at the top of the list for further investigation. The next phase of this mission is all about getting direct evidence of habitability, and that's where the big guns come in. One of the most ambitious upcoming projects is the Habitable Worlds Observatory, or HWO. Unlike previous missions that relied on indirect detection methods, watching for tiny dimmings of starlight as planets passed in front of their stars, HWO aims to see these planets directly. That's no small feat. Imagine trying to spot a firefly hovering right next to a floodlight from miles away. The light from a planet is drowned out by its star, making it nearly impossible to detect. To solve this, NASA is developing high-tech coronagraphs and starshades, specialized instruments designed to block out the overwhelming glare of stars while allowing the faint glow of planets to shine through. Direct imaging isn't just a fancy trick. It's a game changer. Being able to capture light from an exoplanet means scientists can analyze it through spectroscopy, breaking it down to see what's in the planet's atmosphere. If there's a mix of oxygen, methane, and water vapor, that could be a massive hint that something biological is happening there. The search for these biosignatures is the ultimate goal, because it would be the first solid evidence that life isn't unique to Earth. Meanwhile, another mission, the Habitable Exoplanet Observatory, or HABEX, is gearing up to take exoplanet imaging to the next level. HABEX is bringing in one of the most ambitious tools ever designed for planet hunting, a starshade. Picture a giant, flower-shaped spacecraft positioned thousands of miles away from a telescope. Its only job is to block out a star's light, letting the telescope focus on the tiny, dim planets orbiting it. This technology could allow scientists to capture direct images of planets that are tens of billions of times fainter than their stars, a feat impossible with current instruments. Another mission, Pandora, is designed to separate exoplanet signals from the noise created by their stars. One of the biggest challenges in studying exoplanet atmospheres is that variations in a star's brightness can mimic atmospheric signatures, leading to misleading results. Pandora will simultaneously observe exoplanets and their stars to filter out these effects, giving scientists more accurate readings. NASA isn't going at this alone. The hunt for exoplanets is a global effort, with space agencies from around the world joining forces. The European Space Agency is preparing to launch Plato, a mission that will provide critical data on the structures and compositions of exoplanets. Meanwhile, the James Webb Space Telescope, a collaboration between NASA, ESA, and the Canadian Space Agency, is already delivering groundbreaking insights. JWST's infrared instruments are revealing details about exoplanet atmospheres that were impossible to study before, making it a crucial player in this search. Finding a truly habitable exoplanet would be one of the most significant scientific discoveries in human history. The implications go far beyond astronomy. If we find a planet with clear signs of life, it would confirm that life isn't unique to Earth. That would mean that the universe is teeming with biological diversity, changing everything we thought we knew about our place in the cosmos. On the flip side, if the search turns up nothing, it could mean that Earth is a rare exception, an oasis in an otherwise barren universe. Either way, the answer would be profound. But beyond science, the search for exoplanets captures something deeper. It fuels curiosity, inspires innovation, and reminds us that we're part of something much bigger. Every new discovery brings us closer to answering one of humanity's oldest questions: are we alone? With each passing year, the search gets more intense, the tools get sharper, and the possibilities grow wilder. The coming decades could bring discoveries that blow our minds and redefine what it means to exist in this vast, mysterious universe. The hunt is on, and the biggest revelations might be just around the corner. Could the discovery of alien life be just around the corner, or are we truly alone in the universe? Leave your thoughts in the comments, and don't forget to like and subscribe for more.